In the Orion constellation, there exists a star that has fascinated astronomers for an exceptionally long period. This red, truly colossal star is far larger and more massive than our Sun. In recent times, Betelgeuse has been behaving in particularly unusual ways. It has significantly shrunk and has even begun to pulsate violently. This has led to speculation that this once magnificent star is heading toward a dramatic explosion. But what if we're actually witnessing the onset of an even more complex and unsettling event? What if Betelgeuse doesn't explode, but instead collapses in on itself? Join us as we explore the latest research on Betelgeuse and its potential consequences for our planet. Through this study, we aim to understand the profound impact Betelgeuse's demise could have on the future of the cosmos. The enigmatic secrets of Betelgeuse, a gigantic star many times larger than our Sun, are among the universe's most intriguing. Yet its size comes with a price. Stars like Betelgeuse have brief lifespans, and Betelgeuse is no different. It's a ticking time bomb, primed to explode, but the exact moment remains uncertain. Located roughly 650 light-years from Earth, Betelgeuse has astonished scientists, shining as one of the closest stars to us. We marvel at its brilliance, trying to unlock the mysteries buried within its fiery core. However, only about 13.3% of its luminous energy is visible to us. If we could witness its full glory, it would outshine Sirius in the night sky. Picture a massive star with a size roughly that of our Sun, extending beyond the asteroid belt and almost touching Jupiter. In such a vast domain, Earth, Mars, Mercury, and Venus would be overwhelmed by Betelgeuse's immense gravitational force. But the surprises don't stop there. Every few centuries, Betelgeuse sheds a mass equivalent to that of our Sun, ejecting its outer layers in a brilliant display of dazzling grandeur. A cloud, often larger than the star itself, envelopes Betelgeuse, cloaking it in an ethereal haze that captivates our attention. This cloud, extending up to 30 light-years, invites us into a magnificent, grandiose spectacle, tempting us to uncover its mysteries. To understand the essence of this star, we must dive deeper into the core of Betelgeuse, where hydrogen undergoes nuclear fusion to form helium in a massive reaction. Over time, the star's hydrogen supply dwindles, leading to dramatic transformations. As helium fuses with carbon, it produces light that travels across the universe. But even this brilliant fusion process has its limits. As neon fuses with iron, a crucial transformation occurs. The star's gravity, weakened by its lack of energy, triggers an imminent collapse, pushing Betelgeuse toward a fate that is both awe-inspiring and tragic. A colossal explosion. Betelgeuse's destiny undergoes a mesmerizing evolution, shifting from the vibrant blues of youth to the fiery reds of maturity. In the 2nd century BC, Chinese astronomers documented an extraordinary celestial event. Betelgeuse's distinct yellow hue set it apart from the cosmic tapestry. Over the centuries, the baton of observation passed to Greek and Roman astronomers. For instance, Tycho Brahe in the 2nd century AD in his detailed records described Betelgeuse as having an orange or reddish appearance, a characteristic that still fascinates us today. This persistent color, noted across cultures, including ancient civilizations, adds to the allure of Betelgeuse. A new chapter unfolds. Betelgeuse's story took an unexpected turn in 2019 when it suddenly dimmed. Initially, scientists speculated that a vast dust storm erupting from the star's surface had obscured our view. However, the origin of this cloud remains unclear. Some researchers propose that a massive object, perhaps a planet, may have disrupted the star's surface or even been engulfed by it. Recently, Betelgeuse has become twice as bright as usual. This is remarkable as stars typically dim as they age. Researchers remain uncertain about the cause of this sudden increase in brightness, though they acknowledge that stellar luminosity can fluctuate for a variety of reasons. For instance, some stars go through cycles of brightening and dimming. Betelgeuse is classified as a variable star because it consistently changes in brightness, expanding and contracting regularly, altering the amount of light it emits. This is a common phenomenon in many stars, including Aldebaran and roughly 30 other stars visible to the naked eye. An ongoing explosion within Betelgeuse's core has been happening, causing the expulsion of stellar material into space and creating an enormous dust cloud of monumental scale. This dust veil blocked much of Betelgeuse's radiant light, transforming it from a brilliant beacon to a dimmer star in the night sky. Betelgeuse's brightness plummeted to levels previously unimaginable. Once ranked among the 10 brightest stars, it now stands below 20th. In the months that followed, Betelgeuse's behavior has bewildered astrophysicists, challenging established theories of stellar dynamics. Speculations abound, seeking to explain Betelgeuse's unpredictable behavior. Some suggest that enormous sunspots or dust clouds are responsible for its erratic fluctuations, while others explore the possibility of recurring patterns. Their studies have uncovered the unsettling notion that Betelgeuse's supernova may have already occurred. Yes, you read that correctly. While earlier predictions suggested that Betelgeuse's massive explosion was centuries away, current evidence now points to a different narrative. The consequences of a supernova explosion could be profound. The last significant cosmic explosion in our vicinity, the Kepler supernova, illuminated the sky many years ago. Researchers have proposed models indicating that Betelgeuse is in the final stages of carbon burning, suggesting that it could be nearing its explosive end. This makes it a strong candidate for the next anticipated stellar explosion in our Milky Way galaxy. Like a grand finale in a cosmic symphony, Betelgeuse remains a prime contender for the next monumental explosion in our cherished Milky Way. However, focusing on Betelgeuse is like solving a puzzle with conflicting perspectives. There are signs of material expulsion and possible recovery, hinting at a mass loss event, but on a smaller scale compared to our Sun observational challenges, and the unpredictable nature of stellar explosions make this task even more complicated. The main difficulty lies in the current inability to observe Betelgeuse with pinpoint accuracy. Researchers have studied Betelgeuse for years and noted that its brightness has fluctuated, suggesting that the star is aging and could soon go supernova. However, there is not enough data to predict the exact timing of this event. A massive explosion, while spectacular, would not pose a threat to life on Earth, and it would be perfectly safe to observe from our planet with the naked eye. To grasp Betelgeuse's role in cosmic evolution, we must recognize its pivotal position in the life cycle of stars within our galaxy. Its evolution provides a glimpse into the fate of other massive stars, offering essential insights into the end stages of stellar life and the impact of supernovae on the galactic environment. To truly understand Betelgeuse's significance, we must examine its stellar structure, life cycle, and the broader implications of its potential explosion. Betelgeuse, categorized as a red supergiant, is a result of the later phases of stellar development. In contrast to smaller stars, which consume their hydrogen fuel at a slower pace and enter a red giant phase, massive stars like Betelgeuse burn their nuclear fuel much more quickly. This accelerated consumption causes the star to expand outward, creating a supergiant. Betelgeuse's core is mainly made up of helium and heavier elements, such as carbon and oxygen. As the hydrogen in its core depletes, fusion reactions commence in its outer layers, causing the star to enlarge. This process is driven by the subtle equilibrium between gravitational forces and radiation pressure, which ultimately leads to the star's supergiant phase. Betelgeuse's core fusion process continues to sustain its enormous brightness and size. Initially, hydrogen fuses into helium, releasing massive amounts of energy. As hydrogen runs out, the core contracts under the force of gravity, causing temperature and pressure to rise. This allows helium to fuse into heavier elements like carbon and oxygen. During this stage, Betelgeuse's outer layers significantly expand, contributing to its immense size and characteristic red color. In supergiants like Betelgeuse, this process is complicated further by the star's high mass. The core undergoes several fusion phases, creating concentric shells where various elements fuse. Each fusion stage alters the core's composition and energy output, influencing the star's dynamic behavior and eventual instability. When Betelgeuse depletes its nuclear fuel, it will no longer possess the energy needed to counteract the gravitational pull of its own mass. This results in a dramatic collapse of the core, triggering a supernova explosion. The supernova sequence proceeds in several rapid stages. 1. Core collapse without enough fusion pressure. The core succumbs to its own gravity, collapsing at an astonishing speed and potentially forming either a neutron star or a black hole, depending on its mass. 2. Shock wave formation. The collapse generates a shock wave that spreads outward through the star's outer layers, heating them up and initiating a dazzling explosion of light and energy. 3. Ejection of outer layers. The outer layers of the star are expelled into space, enriching the surrounding interstellar medium with heavy elements. This expelled material aids in the formation of new stars and planetary systems, continuing the cycle of stellar creation. Betelgeuse's impact on its galactic environment will be profound. The explosion of a massive star like Betelgeuse can influence the formation of new stars and planetary systems. The shock waves from the explosion may cause nearby molecular clouds to collapse, leading to the birth of new stars. Furthermore, the heavy elements produced in Betelgeuse's core and released during the supernova play a crucial role in the chemical enrichment of the universe. These elements are essential for the formation of planets and the emergence of life. Therefore, Betelgeuse's life cycle plays a pivotal role in shaping the chemical makeup and structure of our galaxy. Since ancient times, Betelgeuse has been a prominent feature in the night sky, influencing many cultures and astronomical studies. Early civilizations documented and observed celestial objects, including Betelgeuse, which was noted for its distinctive color and luminosity. In ancient Europe, Betelgeuse was associated with various myths and deities. Its reddish tint and position within the constellation made it a key reference in the sky. Its visibility and fluctuations in brightness were often interpreted as omens or signs by different societies. Betelgeuse has become a focal point for astronomers due to its unusual behavior and the potential for a supernova event. Advances in observational technology, such as space-based telescopes and high-resolution imaging, have enabled scientists to study Betelgeuse with unprecedented precision. Researchers employ various techniques, such as photometry to track brightness variations and spectroscopy to analyze the star's chemical composition, to gain a clearer understanding of its present state and predict its future evolution. Predicting the exact timing of a supernova is a difficult task. Although scientists can estimate the probability of a supernova based on a star's age and characteristics, precise predictions remain elusive due to numerous factors. Variables like the star's mass, composition, and surrounding environment can influence the timing and nature of the explosion. While current models of stellar evolution and supernova mechanisms offer valuable insights, much is still unknown about the specific conditions that trigger a supernova. Ongoing studies of Betelgeuse and other massive stars are essential for refining these models and improving our understanding of these cosmic phenomena. Examining Betelgeuse provides essential insights into the evolution of stars. By studying its behavior and attributes, astronomers gain a deeper understanding of the life cycles of other massive stars and the processes leading up to supernovae. Betelgeuse's extraordinary characteristics, including its size, brightness, and erratic behavior, offer valuable data for testing theoretical models of stellar evolution. Additionally, understanding Betelgeuse's dynamics helps astronomers contextualize broader star formation processes and galactic development. The star's interactions with its environment and its eventual supernova will contribute to the ongoing cycles of stellar evolution, shaping the formation of new stars and planetary systems. Betelgeuse's dramatic behavior has captivated the public imagination, fueling widespread interest in astronomy. Educational initiatives and popular science outlets frequently feature Betelgeuse as a fascinating example of the dynamic forces at play in the universe. Engaging the public with these topics sparks a deeper interest in science and enhances understanding of cosmic phenomena. As technology continues to evolve, future observations of Betelgeuse will provide even greater detail regarding its behavior and evolution. New telescopes and advanced observational techniques will allow scientists to track the star's activity with greater accuracy, offering fresh clues about its impending supernova. Researchers are also utilizing computational models and simulations to improve our understanding of the processes occurring within Betelgeuse and other massive stars. These models will assist in predicting Betelgeuse's future behavior and refining our comprehension of the forces that drive supernovae. The study of Betelgeuse offers a fascinating glimpse into the life cycle of massive stars and their profound effects on the cosmos. From its immense size and complex fusion processes to its potential as a supernova candidate, Betelgeuse remains a key subject in cosmology. As we continue to study this remarkable star, we gain critical insights into the dynamic forces that shape our universe. Its eventual explosion will not only be an extraordinary event, but will also contribute to the ongoing processes of star formation and chemical evolution within our galaxy.